Hello and welcome to episode 2 of this live streamed AI driven live coding session. You can join this stream by joining the VizHub Discord. And if you go to vizhub.com, you can see resources, Discord. And so if you join the general voice chat channel right now, you can chat with me live and your voice will be broadcast to the stream. In the last stream, we worked up these examples, this React and D3 starter, the pseudo scatter plot with just circles, the clickable circles. And since the last live stream, I worked up this new example, responsive clickable circles. So I want to start there because this will be what we branch off of to create visualizations. And I was thinking, in what order should I cover this material? And I think it makes sense to address the idea of responsiveness first before we address some of the actual data visualization challenges. So I'll do maybe a quick recap of all of these and then dive into responsive clickable circles. The React and D3 starter pulls in React stuff and D3 using import maps, and then we use JSX to set it up, and then we have a use effect, and this is where we use D3 to do the DOM manipulation. The pseudo scatterplot example has an app.jsx that calls this viz function in a use effect, in a side effect. And this establishes a pattern where viz.js calls some other function called render circles, and this uses D3 data joins to render circles. And the data is just defined here in a data.js file. One of the other things I want to do shortly is move this data into a CSV file, which is more like what you'll actually do with real data visualizations. And then there's the clickable circles example, where we can click these and they change color. The way this works is we now have a use state from React to keep track of a piece of state called selected circle ID. And then whenever a circle gets clicked, we update that. And we set that up using the on-click feature of D3 selections. But what if we want to make this responsive? See, if I open this in a full screen, if I click on the button that says open in full screen, I can open it here in a new window, but then when I resize this, it doesn't update or anything based on the size of my screen because there's just hard-coded values for the dimensions. Or rather, no, it's not hard-coded, but it uses container.clientWidth. And so there's no mechanism to trigger this to re-update the dimensions when the size changes. So this just uses the measured container width and height on page load. And that container is this parent div here. What I would like to do is use this API called resize observer to attach an event listener to this specific div that will be notified when its size changes. And that's exactly what's done in this new example, responsive clickable circles, which I will now do a sort of code review of, so we're all on the same page. With this example, if I open it in a new window like this, we can see that it responds to resize. And this is great for adapting visualizations that need to fit within some kind of a dashboard. Like if you have a page with, I don't know, Tailwind, CSS, and Flexbox, things like that to manage your page layout, you can just drop SVGs into there, driven with JavaScript and D3. And if you set it up like this with this resize observer, you can pretty reliably get the size that you want from your layout and then fit your visualization into there. It's also good for simulating mobile. So if you open the dev tools and click on toggle device, then you can simulate different screen resolutions. This is super useful if you're developing mobile-first visualizations. And I know a lot of traffic to, say, news sites is mobile devices, phones. And you can simulate what it is on different phones. So like the Samsung Galaxy S8 Plus would look like this. And this simulates the mobile touch events as well. So you can debug interaction on mobile devices. This is the end result of using this resize observer. Let me show you the code for setting this up. In this example, there's a brand new custom React hook called use container dimensions. What this does is takes as input a div ref, a reference to the div in question that we want to measure, and it sets up a resize observer, and it returns the dimensions as an object with width and height properties that gets initialized to width and height of 0. So that's what's being used here to check if we have the initial measurement of that div. And then when we do, we just pass that into our viz function, which we had before. So nothing within that function changes. It's just this outer layer that will measure the dimensions and pass them in. But how do we get this div ref? This is new. Now we actually have two refs, the div ref and the SVG ref. And the div ref is for the outer div that has a class of container. This fills up the entire screen. And then there's an SVG ref for the SVG, which we use for the viz function. So that's how we get access to this DOM element, and then we pass it into use container dimensions, which is defined right here. The way use container dimensions works is it's a function, but because it starts with use, we call it a custom hook. It's just a fancy way of saying it's functions that can use React hooks. It's a React specific thing, custom hooks. It's a fancy name for a function. But anyway, inside of here, we have a piece of state called dimensions, which gets initialized to an object with width and height as 0. That's fine, I guess, for it's consistently typed, at least. Another way you could do this is initialize it to be null, but this is fine, I think. And then there's a side effect. And what this side effect does is it sets up a resize observer. Resize observer, documented here in MDN, is a browser API that you can use to essentially observe changes in the size of elements on the screen. And here's how it works. First of all, we need access to the div. So if we, for some reason, don't have access to it, we return early. I don't think that's required. So I'll just remove that. And then we set up a resize observer. And when we set up a resize observer, it's not connected to any specific element yet. That comes later. All that we're doing here is specifying a callback function that will get called when this element gets resized. And there's just kind of a quirky, in my opinion, it's a quirky API where you get this array of entries, and then each entry has a thing called content rect that we unpack to width and height. And then we just use that to define a new object that we set to be dimensions. So this is just translating the resize observer API into a React state. And then to actually connect it to that specific DOM element, we have to call resize observer.observe and pass in the reference to that DOM element. And this also handles the idea of disconnecting, which we don't need in this case, but if it's a React application where this component gets instantiated and then removed from the page, then this disconnects the resize observer. So it's like a clean way of cleaning things up on mount. So anyway, that's our custom use container dimensions hook. And that's how you create responsive clickable circles. And let me point out that the clicking and resizing are both preserved at the same time. And this is a really important sort of sanity check just to know that we're dealing with state properly. Because sometimes you get weird glitches where part of the state gets reset at the wrong time, but we don't have any of those bugs here. That's because we have two separate independent calls to use state. One for the container dimensions, and another for the selected circle ID. So whenever either of those change, the entire app gets re-rendered, and then our visualization logic, because we have the dependencies here of dimensions and selected circle ID, because both of those are listed here as dependencies of this use effect, that's why all this code runs every time either one of those change. So it's like two streams of event sources sort of feeding into one. Now that we have these responsible, responsible circles, now that we have these responsive clickable circles, I want to take this one step closer to an actual data visualization by moving the definition of the data from a JavaScript file into a CSV file. CSV stands for comma-separated values. It's a text-based data format that can represent tables of data, kind of like spreadsheets. In fact, you can export from Excel or Google Sheets to CSV. And it's also pretty easy, to extract database query results as CSV. I'll start by forking this example and call it CV loading CSV data. And I'll try the AI editing, and I'll say, change this so that the data lives in a file called data.csv, and use D3's utility for fetching and parsing that CSV file. I'll send that off. It's making some edits. It broke it. So I'm going to say actually try harder. Yeah, so now it's creating the CSV file. Good, good. Okay, that worked. So now it's still clickable, and it should still be responsive, and it is. I think I'll just review the diff for this one. So we create a new data.csv file. This is what CSV looks like. Each row gets parsed as an object, and this has ID, X, and Y. Just like what we had earlier, but now it's in CSV format. This first row is called the header row, and it defines the field names, and each row matches up to those field names. So ID is 1, X is 100, and Y is this number here. Then, in app.jsx, we are importing CSV from D3, introducing another useState call to define data and set data, and then, in a totally independent side effect with no dependencies, we call CSV, the function from D3, and we pass in data.csv in quotes, which is the file name to load. That function returns a promise. So to sort of intercept the result from that promise, an asynchronous operation, we call .then and pass a callback that will be called once that promise resolves. And it will be called with this value we call loaded data here. And then what it's doing is it's saying loaded data.map. And for each row, for each original object, it's creating a new object with the strings parsed into numbers. CSV doesn't encode types at all, and so when it comes in from the D3 CSV utility, all of the fields are strings, and we need to write our own logic to parse those strings into whatever the correct type may be. In this case, they're all being parsed into numbers with the unary plus. It's a weird operator in JavaScript, the unary plus, that little plus sign, but it parses strings to numbers. That's what it does. And array.map creates a new array with all of the results. So parsed data is this new array with objects that have ID, X, and Y, all as numbers. And that's what we pass into set data, which triggers a re-render, and then data gets defined as that new array. And then we have an early return on the side effect that renders the circles that says, okay, if there's no data, return. But why can it say data.length is 0? It's because of how the state was initialized to an empty array. So that's how it works. That's how you can load CSV data into a responsive SVG graphic. This is pretty much all the ingredients we need for a real data visualization, like a scatter plot, which is what we'll do next. Now that we have this loading CSV data example that loads from CSV, renders some circles with React and D3, and also has this clickable feature, which we can throw away. It was just to test the idea of state. But now that we have all these ingredients, we can make an actual scatter plot. Let's do that. I'll start by forking this, and I'll call it CV scatter plot. Click fork. And then what I'm going to do is swap out this data.csv to contain an actual data set. And for a demo data set, for a scatter plot, I love the iris data set. It's very cool. Some people say it's overused. There's also the penguins data set or cars. But like, just to get an example running, I'm going to use the iris dataset. It makes beautiful scatter plots, just as a demo. It's from this website here, the UC Irvine Machine Learning Repository. It's a very widely known, widely used dataset where each row represents a flower, an iris flower. And because it's so well known, there are these various diagrams that people have made of like, okay, this is the sepal. Yeah, like this is the sepal, this is the petal. They're different parts of the flower that can be measured independently. And so that's what these measurements are. And there's different species of these flowers that have sort of patterns in this data where you can just use these measurements to figure out what species it is. But anyway, I put this into CSV format in this gist right here. This is what the tabular view looks like. If I click on raw, it's CSV data. And then I'll use Control A to select it all, Control C to copy it, and then paste it into data.csv. And so now the code is no longer aligned with the data. So let me use the AI editing to say something like, make a scatter plot of the updated data. And it worked. This is kind of too much though. Let me say something like, make it black and white just with circles that are all the same size and black. Yeah. And then add axis tick marks. There we go. Decrease the top margin by about half. Make the font bigger. Add 50 pixels to the left margin. Move the y-axis label to the right by 30 pixels. Okay, there's our voice-dictated AI-edited scatterplot. Let's see if the code makes any sense at all or if it's gibberish. But it works, right? So it can't be total garbage. But it's amazing how far you can get with just AI. You know, a sequence of AI code edits. But now comes the code review part where I'm going to critique it and explain it and make sure it's decent. In app.js, the data parsing looks good. We're mapping over it, and we're also assigning ID, which is kind of nice. Oh, are these still clickable? Yeah, they are. Amazing. Ha, okay. Yeah, that's used for the clicking. And then not much has changed here. We invoke a viz.js, which calls render circles. Now, oh, this is complete garbage. Don't use hard-coded values here, but rather use the available width and height, and use the extent utility from D3 to compute the domains. Also, pass in accessor functions called xValue and yValue from outside the viz function, and pass the axis label strings in from that level as well, called x-axis label and y-axis label. Okay, this looks better. We have a little weirdness with our margins, but I think we'll circle back to it. Let's start the review again from the top. So now, in our app.jsx, when we call viz, this is where a lot of the things are specified that are specific to this data set. And it doesn't really matter to me where this happens, but it matters to me that it's done in one place, because I think it's the best way to organize this code is to have it so that you can change one place in the code to customize it to a new data set. That makes it really easy to fork and modify these visualizations to create new visualizations based on your data and your needs. In this case, we're passing in accessor functions called xValue and yValue. This is just my personal naming preference, where it's just a function that takes as input D, one of the rows from our table, and returns a value from one of the fields. So in this case, it's hard-coded here to be sepal length. But this is also something you could make dynamic. Like in future examples, I think I would love to make one where it's a scatter plot with menus, where if you select in the X menu something else, it would change the value of this. But that's in the future. But for now, they're defined right here, and also the axis labels. So we pass these all into the viz function, which uses destructuring to unpack them here. And it essentially passes it all through to render circles, which I don't quite like, to be honest. So this is kind of a weird structure. So let me just say, migrate render circles into the definition of viz.js. Yeah, let's just put it all in one spot so we can tease it apart nicely later. Okay, it made a function called render circles, but what I was thinking is like all this stuff can go into viz. Just like that, but it broke. Why did it break? Oh, it's called SVG here, but it's called selection here. Okay, so I'm going to call this selection. Or, you know what? It's fine. Sorry, let me just try another approach. So I want to actually stratify this out so that there's one function that comes up with the scales and then another function that renders the circles. refactor this so that there's one function that defines the scales, and another that renders the circles, and another that renders just the axes. These edits don't make that much sense. Let me say try harder. I think this is good. The idea is just to stratify the code so it's not all in one place. So let's see what we have now. Viz.js. I like this. It's pretty cleanly separated into the top level, this viz function, which is kind of like the orchestrator that pulls everything together. And then we have these nice, well-defined functions that we can look at in isolation to really understand what they're doing. There's create scales, render circles, and render axes. And we do the SVG manipulation here. And we could do that in React too, like, doesn't matter really. And here we define the margin. Oh, but you know, we should pass in the margin from the outside. See, this is a tweakable. A tweakable is, in my view, something that can be tweaked. And I like to centralize all the tweakables. And so let me do one pretty small AI edit, which is define the margin outside of the viz function and pass it in. So now the margin is defined externally and passed in there. It's a variable, but that's fine. But really, I would like to see inline the margin right after the x-axis label and y-axis label definitions in the function call. Yeah, I like this. So now we end up with a viz function call where these are all the tweakable things: the accessors, the labels, and the margin. So that gets passed into the viz function. We have this create scales function, which takes as input a lot of things, but I love this. I love this. These are the things we need to figure out the scales: the data, the width, the height, the margin, the accessors. And it returns an object that gets destructured to two local variables, x scale and y scale. I think this is pretty clean. I like this. So now let's take a look at create scales. And I suppose we could further break this down into create y scale and create x scale, but this is fine. Now, this is super sketchy. Don't do this. Don't do this. Just use extent from D3. It's a weird extra margin thing that's there for some reason. Try harder. Seems to be a glitch in this. Oh, there goes. Hell yeah, this is correct. Okay, so this is much cleaner. Now we have a nice, simple, well-defined create scales function that creates two scales, x and y, using scale linear from D3. Linear scales, according to the D3 docs, map a continuous quantitative input domain to a continuous output range using a linear transformation. So that's kind of filled with jargon, but what it means is there's the domain, which goes from some minimum to some maximum, and then there's the range. And that domain is sort of translated into that range by like stretching those numbers. So if the domain is like 0 to 1 and the range is 0 to 100 and you give it 0.5, it'll map that to 50. Like it'll map the middle to the middle and so on. But anyway, there's also this extent utility that computes the min and the max. And the way this looks like from the code perspective is this is the definition of the scale. We create an instance of scale linear. We use method chaining to call dot domain and then dot range. And when we call dot domain, we pass in the extent of the values returned from the x value accessor when mapped over all of the data and the max. So the min and the max of these x values. It's an array with two elements, the min and the max. And then for the range, this is the screen space, like the pixel coordinate representation of where we want these values to go. So this x scale is the core mechanism by which data values get translated from data space to screen space. So data space being like the domain, the min and max of the sepal length, and then the range being the screen space, the min and max of this rectangle on the screen that goes from where the axis begins to where it ends. Now, there's this thing called .nice, which makes sure that the scales begin and end on so-called nice numbers, like in this case 4. See how that tick mark for 4 is right there on the edge? But I don't really think that's necessary, and I kind of prefer not to have it. So when I remove the .nice, it just actually maps the data onto the screen space. So that means we'll have one point that's exactly at the edge. And then same thing for y scale, but with y you got to watch out that the coordinates are reversed. So the first value of the range is height minus margin dot bottom, because the x and y coordinates, when you have a 0, 0, that's the upper left, not the bottom left. And so as the y coordinate increases, it goes down on the screen. So we start at height and we subtract margin dot bottom to get this y coordinate here. And then the other side is margin dot top. So this is how your x and y scales can be defined. And then what else have we got? Render circles now accepts as input these new options: x scale, y scale, x value, and y value, because it needs those to calculate the circle coordinates. So let's take a look at render circles, the updated version. So we use destructuring to get at all of these options. And then it's just one big expression, which is the D3 data join. That's this here. So after this little incantation, we have access to all the circles. And then we set the CX attribute, which is the center x coordinate of the circle, to be the result of this function for each row. Namely, we take the row, we pass it through x value, the x value accessor, to get at whatever that value is that's mapped to x. And in this case, it'll return the sepal length, specific number, in centimeters of the length of this flower part. And then that becomes a value in the domain of the scale. It's in data space. And so this x scale, and D3 is kind of a weird API. When you create an instance of a scale, it creates a function that you can call that also has methods on it, which is kind of a quirky JavaScript thing. But anyway, it's a function where you pass in a value from the domain, and it returns a value from the range. And in this case, it's the pixel coordinate that we need for x. So it's the same thing for x and y. Ideally, we wouldn't hard code this 8. Let me just say, don't hard code the value of 8 for the radius, but instead pass that into the viz function and pass it down so it's configurable. Call it circle radius. Yeah, that's good. So now we accept it as input. We define it externally and pass it in. But one last thing, please inline the definition of circle radius with the other options. Nice. So now we have right here all of our tweakables collected into one spot. And this is the pattern, by the way. If you ever want to expose another thing as tweakable, I think this is a good pattern, like the circle color or what have you, various things. And now that we're here, let me just tweak the margin a little bit, because there's a lot of space on the left side. So let me just hold down Alt and drag this to tweak that. Okay, cool. So moving on, within render circles, this essentially renders all the circles. And then it sets the fill to be black, which we don't actually need because that's the default fill. And then it does some stroke around the clickable feature, but we don't actually need that. But it's kind of cool that it's still working. But, you know, if it's still working, let's at least style it properly. Look at that. It looks terrible when you click on it. ideally we could make it so that the selected circle has a thick stroke and a fill of white. Yeah, there we go. That's cooler. So now when I click on it, it's a totally different style. I think it's kind of cool that this is baked in. And we don't necessarily need this right now, but this could be the foundation for a lot of things, like maybe tooltips. Could do it on hover, or you could use a scatter plot as a navigation mechanism to select one item and then have a detail view somewhere else with that specific item. So even though it slightly complicates the example, I'm going to keep that in here. But it's kind of cool because it's pretty simple conditional logic that says if it's the selected circle, use this specific color. And then the stroke width is different. And then cursor pointer to give that affordance when you hover. Opacity 0.7, that's a cool trick actually that we can use to see density. Like see that if I pull it down, we can see where there are a lot of overlapping circles. And that's another tweakable. Introduce a new option for the opacity of the circles. Similar to circle radius, but called circle opacity. Nice. So now it's not hard-coded, and it gets passed in from the outside. Okay, cool. And then there's the click handler, same as before. The last part of this is the axes. Let's take a look at what's happening there. So after we create our scales, render our circles, then we render the axes and pass these various things in. And that's defined here, render axes. We start with the x-axis, and then the y-axis, and then the axis labels. So let's just go through these step by step. For the x-axis, we use axis bottom from D3. We pass into it the x scale so that it knows what scale it's dealing with. And then we set dot ticks to be 5. This is optional, but we can use this parameter to define the number of ticks. See if I say 50, it gives us 50. And there's some default, which is usually pretty good. Maybe I'll just use the default. It simplifies things. And then it's doing something that I really don't like, which is selecting all x-axis and then removing them. No, this is ridiculous. It's not using D3's data join. Use D3 data joins properly in this case. And then I'll paste that code with .data null. Just as a hint. Let's see if it gets it. Yeah, this is better. So we are using a data join on the x-axis group element. This is exactly how it should be, in my opinion. What it's doing is saying select all things that have a class of x-axis, compute a data join with a single element. And so this will create them. And then once it's created, we need to give it a class of x-axis so that it will be selected the next time this runs. But anyway, this is our data join for managing a singular group element. And then we do the transform translate thing to move it around. And see, if we don't do this, it ends up on the top there. And so this transform translate moves it down to the place where it's supposed to be, which is height minus margin dot bottom as the y coordinate of this translate domain specific string. And then we use .call to invoke the x-axis function. And .call is a kind of a strange at first pattern of calling functions. It's exactly the same thing as, let me just show you, x-axis passing in that selection. And in a way that's cleaner, but in a way it's kind of weird because you're doing a whole definition inside of a parameter to a function. So that's why .call was invented, so you can kind of have this nice smooth method chaining and it all kind of flows together. But it's just a way of calling a function and passing in the selection that you're chaining on. So that's it. And by the way, this is a place where the D3 DOM manipulation really shines. So x-axis is doing DOM manipulation, and you can see what it creates if you inspect these elements. You can see that for each tick there's a group that has a line and some text. That's pretty nice how it does all this internally. And it also deals with transitions. So you could have like smoothly moving axes, which is cool. That'll come later. But anyway, we're doing the same thing for the y-axis. We don't need those custom ticks. And then we are rendering the axis labels. And this is always kind of tricky to get right, but the AI is really good at this kind of thing. What it's doing is doing the data join on a singular text element. And then, oh, I don't like this -10. What is that? What impact does that have? It's like the label offset. Don't hard code the label offsets, but rather introduce new options passed into the viz function for those. E.g., this should be height minus, let's call it x-axis label offset. Let's see if it works. Yeah, that looks correct. So now we have two more tweakables, x-axis label offset and y-axis label offset. And these do need to be tweakable independently from the margin because it controls a different thing, which is how far away the text is from that thing. And now that it's tweakable, let me go in and tweak it because it needs a little work. See, now I could just control where this is here. So I'll center it nicely. 29, call it 30. So now it's like a little configuration for our data viz. So if you want to swap out the data set, you just tweak all the tweakables right here. But anyway, render axes is actually a pretty big file. I kind of want to split out this logic. Split out the following logic into a separate new function called render axis labels. And I'll put that triple backticks and drop that code in here. Refactor early and often. Okay, so now, okay, it's nested, which I guess is fine. At least it's stratified a little bit. Okay, I'm just looking at this and I'm seeing that we don't actually need these variables if we're just passing them in there. Yeah, so let me just simplify this a little bit. Pull these definitions into the call. And I kind of want to call this from the outside. Although, let me see what it looks like there. Viz.js. See, it's funny how long the files get with just calling these functions too, because there's so many options. This is the prop drilling issue that is solved in React with contexts. And it's not something I've fully solved with this approach. But anyway, I think this is fairly clean. Create the scales, render circles, render axes. And then within render axes, it calls render axis labels. That's pretty clean. And so now it's just doing all this setting up of the text elements. And it's funny, the rendering of the axis labels is where a lot of complexity comes because so many things are tweakable. You've got the font size and everything. And we can use CSS too. Like a lot of this can be moved to CSS. We have a styles.css. Oh, there's a transition on the circles? I'm not seeing that. So anyway, let me simplify that function a little bit by saying move these styles into CSS. Because it's duplicated twice in the JavaScript. We could just apply it to the class. So now we get that as CSS. And we can tweak it like that. And it removed 8 lines from that function, which is pretty nice. Okay, now it's like a reasonable size. Oh, but look, it actually broke it. Oh no, it broke it. Let me go back to the previous version. And let me be a little more specific this time, because I don't want it to move the rotate. Move only these styles to CSS. Keep the rotate in the JavaScript. And then I'll say triple backtick. Okay, there we go. That's better. So we still got rid of 4 lines, and we added like 5 lines to the CSS. Nice little compactification. So there it is. We set up a singular DOM element, give it the classes, we set x and y. So in this case, width over 2 puts it at the center point, and then y puts it at height minus x-axis label offset. And one thing to note is that the way it's set up here is that it's configured as an offset from the total viewable box. And so if you tweak the margin, it will not actually move the labels. But since they're independently tweakable, I think it's fine. And then, yeah, the transform rotate is here as well, which rotates this text. That's it. That's it for our scatter plot. Any questions? Now that we have a scatter plot, we have the so-called stem cell for various visualization types. So I believe it will be pretty fast to do 2 visualizations based on this. So I plan to fork this and make a line chart, and fork this and make a bar chart. So let's do the line chart first, see how it goes. I'll start by forking this. And I'll call it CV line chart. And I mentioned it before, but in case you missed it, CV stands for Constructing Visualizations, the name of the textbook I'm working on. These are examples that will feed into my textbook. So I'll fork this. And then, you know, I did a number of different takes on this. So let me just grab the data from a previous one that I did. The Keeling curve data. So the Keeling curve data set, let me just show real quick. The Keeling curve is a wild data set that shows the carbon dioxide concentration at Mauna Loa Observatory in Hawaii. And it's beautiful as a line chart. I think it's a perfect example data set for a line chart with a single line that is pretty impactful. And it just shows how it goes up, and you've got these yearly periodic trends that you can see, but it's going up and up and up. So I've got it here as CSV. I'm just going to copy that text and paste it to replace the iris data set in our new line chart example. And then I'm just going to ask AI change this from a scatter plot to a line chart visualizing this data. And I want to be a little specific about it. As in X should be the date and Y should be the CO2 field. Send. It didn't show up. Let me say try harder. Wait, sorry, I think there's a bug. Scratch that. So here's what I'm going to do. Just copy this data for the Keeling curve into our brand new line chart example, overwriting the iris data set. And I'll run it and it will be broken. But now we can use AI to make a visualization that's a line chart of this data. Change this from a scatter plot to a line chart and delete all the functionality around the selected circle and use the CO2 column to drive the Y value. I'll send this off, see what it does. Okay, it works. Amazing. So reviewing the diff here, it's just got rid of the iris stuff and put some new things for our specific data. Now, it didn't use a time scale, but it basically got things to show up. But I love it how all of our tweakables are tweaked just in one little spot here. And then instead of render circles, now we have render line. And instead of circle radius, we have line stroke. And instead of circle opacity, we have line color. And then here it is, a line generator from D3. And we just pass the data into it. Pretty straightforward, pretty fast to make a line chart once we have a scatter plot. Just make a couple improvements. Be sure to use a scale time and parse the dates properly. Yeah. There we go. Now we have nice tick marks for the date. Show gaps in the line where we have missing data. So it used the .defined accessor, but I think that's filtered out somewhere else, so we're not actually getting the gaps. Let me say try harder. I think the more advanced AI model will get this. No, that looks too complicated. Let me undo that. Okay, it actually did some pretty complicated date parsing logic around Excel date. But in the data, we have year, month, date, Excel date. I want to just simplify this. Let's simplify the date parsing logic based on using D3 time parse and using the following columns. And then I'll paste YR and MN. Yeah, so that just removes a lot of that complicated stuff. And we just create a new date object with year and d.month minus 1. That's a pretty good way to do it. Okay, cool. Now our create scales function just replaces the x scale with scale time. And it's pretty much the same, but now we're taking x domain as a variable, but let's just put it back in there. Now that's the same structure for both. But I'm kind of dead set on representing gaps in the line where there's missing data. So instead of filtering it out like this, let's keep it. And if we do that, look at this kind of broken intermediate state. It goes from the number to minus 999. Now, let me say, use the defined function on the line generator based on the following criteria. And then I'll paste like that. And let's see if it works. No, that's not what I mean. Try harder. Looks like the AI broke or something. Okay, right now we are filtering out the missing data, but really what I'd like to do is show a gap in the line. So let me try this. Remove the following filtering logic and instead make it so that we show gaps in the line in this case, where we get the sentinel value that indicates missing data. Oh look, the other one finished. Oh gosh, there was a delay. It worked from the last one. Okay, that worked. There's now gaps in our line. Let's see the code that does this. Now in render line, we have this additional thing on our line generator, which is the defined accessor, which is another tweakable. Let's define this also at the same level. Add a new option to the viz function that defines the defined accessor, e.g. I'll call it line defined value to be in line with x value and y value, and that could be defined as this function here. Okay, it didn't actually define it. Let me say try harder. It did the same thing. Well, anyway, we don't want this function to know anything about the data set. So we'll just pass in line defined value there. Yeah, because it's defined up in app.js. But yeah, the defined accessor is what defines gaps in the lines. So that's it. That's our simple line chart that deals with missing data. Hooray! Now, let's do the same thing, but instead of a line chart, let's make it a bar chart. I'll start by forking our scatterplot example, and I'll call it CV bar chart. And in the past, I made a bar chart that shows the population of like the top 20 countries or top 10. I think that's a cool example data set to show as a bar chart. So let me just go find that. There it is, simple bar chart. Let's make something like this. This is actually a kind of complicated example because it starts with the UN population estimates. I'm looking for a simpler example. How about this one? All right, so the data set we're going to use for our bar chart is this UN population estimates data set. Ugh, the site broke. Look at that. The United Nations World Population Prospects 2024 dataset is a pretty nice dataset from the United Nations about various countries around the world and their populations, among other things. I think there's a couple other metrics in here too. But this is a data set that we will use to create a couple different visualization types. The first one will be a simple bar chart, but let's use this full data set so that in the future we can use the same one to make something like a line chart with multiple lines with each country to see how the population of various countries has changed over time. So in our new fork of the scatter plot, that's called bar chart, I will replace the old data set with the new data set, this UN population prospects data set. And then I'm going to kind of push the AI a little bit and see how well it can do. Please change this to be a bar chart of the top 20 most populous countries. This will require some data filtering and stuff. Let's see if it can get it. Wow, it did. It did. That's wild. Yeah, so we loaded the CSV, filter it by country, parse out the population, sort it by descending population, and then take the top 20. So that's the data processing. Which I kind of want to refactor. Refactor to split the following logic out into a separate module called use data. And I'll paste the code there. I would error it out. Whoa! Well, the site went down. Let me I think I'll call it for today. But this was a good long session. Thanks thanks for tuning in. And I'll be doing this every Friday. That's the plan. So maybe I'll see you in a week's time, and we'll do the bar chart then, and then we'll branch off to other visualization types. Thanks for joining. Take care.